With sports instances, you can cut your SageMaker training costs by up to 90%. So in this demo, I will walk you through how to integrate sports instances into your SageMaker training jobs so you can maximize savings without necessarily sacrificing performance. So let's dive in. So for the benefit of those who might be hearing sports instance for the first time, let me quickly walk you through what that is. A sports instance is an unused EC2 instance that is available at a very steep discount compared to the on-demand instances. It can reduce your SageMaker ML training costs by up to 90%, and it runs on a specific AWS region and availability zone. So now that we've established what it is, let's dive right into the demo. Hello and welcome to this demo session. So the first thing we have to do is to set up our environment, and that's exactly what I'm doing in this block of code. I am setting up my SageMaker session so SageMaker can track everything I'm doing, setting up my bucket, my account ID, fetching my account ID, the role. So let me emphasize this. So this specific role here have access to S3 bucket and have access to SageMaker service. In case you're trying to replicate what I'm doing, make sure that your role also have this access. Okay, so after that I have my checkpoint suffix and checkpoint part S3 part. Further, I will explain in more details as we progress what this checkpoint mean, because it's very crucial for using sports instance to train your ML model. So I'll go ahead and run this code to import all these libraries that I have here. So I'll be working with PyTorch framework, so that's why I'm importing PyTorch. And afterwards, we have to download our CIFAR10 dataset, and I'm using this function to do the download. The function is in the utils, so if you're familiar with PyTorch, you know that this is how you load data from PyTorch. So that's what I'm doing here. So I'll go ahead and run the code to fetch my train and my test dataset. And also I'm using CIFAR10 dataset. It is a dataset that classifies different things. It has 10 classes, and the things it classifies includes things like cars, animals, and all. So yeah, and once you're done downloading that, we can preview the data to see what it looks like. So you can see we have a deer, a sheep, a deer as part of the preview dataset. And now once we have our datasets, we upload it to SageMaker. Upload it to S3 bucket, which is exactly what I'm doing. I'm specifying my bucket and then the folder where it's gonna store the dataset and the path to fetch the data from, which is from this folder here. So let me go ahead and run this code. So we now have our data set in the S3 bucket. So the next thing now is to begin to train the model using the sports instance. So we're gonna set this variable use sports instance to true and our max run to 600 and max width to 1200. Now you may be wondering, what are all these terminologies? Okay, before I explain that, let me quickly explain what a checkpoint is. So its checkpoints are snapshots of a model's training state at a specific point in time. This includes the model weights, the optimizer states, the current epoch, and the loss. And why do we have to save this state? Because you're using a sports instance, and AWS can at any point give you 2 minutes to notice to reclaim that specific instance. And when that happens, SageMaker needs to know where the state of the training is, so that if it's able to fetch back or retrieve another sports instance, it can continue from where it stopped based on the last state of the training. So because of that, you have the concept called checkpoint, and you have to specify your checkpoint path, which is what we were literally doing over here. So this is very critical to ensuring that your sports instance works as expected. And now you have the concept of max run and max width. Max run is the maximum time in seconds that your training job is allowed to run. So once this time is exceeded, SageMaker will automatically terminate the job regardless of its status. This is to not allow the job run endlessly. And also mass wait is the maximum time in seconds that SageMaker will wait for its post instance to become available and complete the training job. If the SageMaker cannot acquire its post instance within this max wait period, then the job will just fail. Because we are using our own training file, so it's more or less like a bring your script kind of training that we are doing. We are not just using PyTorch framework directly to run our code. We have our own training file, which is this train.py. Because of that, we also have to include in that file a way to not only save the model, but also to save our checkpoints and load our checkpoints. So that's just what we're doing, so that SageMaker can know at any point how to access the state of the current state of the training. So that's what we have in this file. And then this model func is just for when during inference, when you want to load your model, how you can load your model. And this save model is simply just saving the model. And this one is just the real training file. So this is kind of outside of what we're doing on this tutorial, so I will not focus a lot on it. All right, so as I mentioned earlier, using PyTorch for this training. We have our training file, our raw framework version, a Python version, the number of instances, the instance type we are using, our hyperparameter. So we want to train for five epochs, and also we are setting use post instance to true here. Okay, so now that we have this stuff, let's go ahead and run this code. Once we run this now, we literally start to train our model, and our input will come from the dataset that we uploaded to S3 bucket, which is this. So let's go ahead and run this code. So the training is getting started. It takes a while as usual, so I'll just wait and resume the video once the training is complete. Okay, so the training is complete, as we can see, and look at the 5 epochs that we trained, and towards the ending you're going to see the amount that was saved because you used a managed spot training instance, and in my case it is 89.6%. So I'm only going to be billed for 56 seconds against 540 seconds. So and you can now decide to deploy this instance. So the spot estimator that we use for the training is this, and we can also use that to do our deployment. So we do spot estimator.deploy, and we specify the instance count and also the instance type. So let's go ahead and run it. So the deployment is ongoing, and I'll just wait a little bit for that to complete. All right, so the deployment is complete. As you can see, usually when it's complete, you will see this mark here, and it will end with an exclamation mark, showcasing that the deployment is complete. Now, okay, so let's go ahead and test this deployed endpoint. So now that we are done with deployment, let us test the endpoint. So we'll first load our dataset, which is what we are doing here, and then we visualize the classes of those images that we loaded, and then we pass those images to the predictor class or object, which is what we created here when we are creating a this predictor object is what we're utilizing here to interact with the endpoint. So we call predictor.predict and pass the images we loaded into it, and then get the generated predictions. So the output is the predictions, and then we simply visualize those predicted values. So that's what we are doing here. All right, so let me go ahead and run the code. All right, so the code has run, and you can see the ground truth and the predicted values. Unfortunately, there's a lot of misprediction. Okay, yeah, 2 of them were predicted correctly, so 50% prediction, 50% of the predicted values are accurate. Maybe the data just needs more training, because it's just 5 epochs, maybe it needs more training, and then it will be more accurate. But that's simply how you can, use the spot instance to train your model, and when you're done, you can just deploy it like I've shown you and locally test it. You can work exactly with this code, modify this code if you're working with PyTorch, but if you're not working with PyTorch, you can check out AWS examples and you can see other examples using TensorFlow, XGBoost, and just utilize those. But the principle is still the same. All right, so I'll go ahead and delete this endpoint um, to keep cost low for me, for myself. All right, so we are done. Thank you for watching, and I will see you in my next video. Bye.